All right, Caden, so here's the first question from the 6.6 quiz. In this particular lesson, we are learning how to find all the possible rational zeros for a given function. Okay, so we find the possible, that's the first keyword here, rational zeros, and then we're going to find all actual or true rational zeros, because even though we find those that could possibly work, it doesn't mean that they all will. So what does that even mean? Like, zeros will work for what? Well, when I look at this function, the question is, first of all, we're going to find what are the possible zeros that I could plug in for each one of these x terms that would make this equation turn out to be equal to 0. So what are those x's? So basically, if this was on a graph, and we're going to look at that in just a minute, but if this was on a graph, you can actually see, once you graph this equation or this function, you can see where the line is crossing the x-axis. That will tell you the actual zeros that we're looking for, what x values filled into this function would make this equal to 0. And so that's what we're going to be looking at. And then from those possible ones, we have to test them and see which ones are actually true rational zeros for this particular function. Okay, so that's enough being said. But let's go ahead and look at this problem. So the first thing that we're told that we do is that we have to take the last term and put it over the first term. So the last term is 1. The first term is the coefficient of that first term that's in your function. In this case, it's 2x to the third. So the coefficient to that term is 2. So in each one of these problems, I wrote this down so that I would get used to remembering what it is that I'm even doing when I list these numbers. So we take the last term and we put it over the first term. So the last term was 1. The first term is 2. That's significant to us because the next step that we're going to do, and I'm going to come down here and do that, we're going to take that 1 and we're going to take that 2 and we're going to list the factors for each one of those. Okay, and I'm going to put a line here just to kind of keep it intact to look like the 1 over 2. So the factors of 1 could be plus or minus 1, right? Because 1 times 1 is 1, negative 1 times negative 1 is 1. So the factors could be either positive or negative. And for 1, that's the only factor that there is. For the number 2, the factors would be plus or minus 1 and plus or minus 2. Okay, so we have to take each one of these. I want you to watch what I'm doing here. Okay, so this would be 1 over 1, positive or negative, right, would give us a positive or negative 1. So the possible, this is what's going to give us our possible rational zeros. So right here, and I'm going to actually change my color. Let's do this in blue, if I could get a hold of it. There we go. So I'm going to write right here the possible rational zeros. Now you can watch me do this all the way through if you'd like, but I would like you to write this down because once you start writing the problems down is when it's going to become solid in your brain. Okay, so the first possible rational zero would be plus or minus 1. And then the second one would be if I took, let me get another color here. I'm having a little trouble. I'll get a different color. I'll take green, I guess. Okay, I have to take that numerator up here and also put it over 2. So if I had several terms across that top line up here, several up here, I'd have to put them, each one of those over each one of the bottom terms. Okay, that's how you figure out your possible rational zeros. So the other one would be plus or minus 1/2. Okay, so that would be your possible rational zeros are right here. But the second part of the problem is asking us to find all rational zeros. So we learned that we could test these by using the synthetic division. That was one way. But that's kind of lengthy, especially if you have a lot of possible rational zeros that you have to plug in and do it for each one of those terms, positive and negative. So we're going to actually not do that. We're going to go to the calculator because that's what the other part of how we learned this. So I don't actually have the calculator, the graphing calculator that you have. So if you're following him, and you really should be doing this, he's teaching you how to use that. You should use that. You need to be able to plug an equation into your calculator and see the graph of that. But I use that Desmos.com. There's a graphing calculator there. And that's what I use. So that's what I'm going to show you right here. So the first thing, I'm going to kind of make this a little bit bigger so we can see it better. You can see that I plugged in the function right here, 2x to the third plus x squared minus 2x minus 1. And as I plug in each term, you see the graph beginning to build. So this is what your graph looks like. Here's the x-axis. Okay, so we're looking for those parts of the graph that actually cross over or touch the x-axis. Okay, that's where x is 0. I'm sorry, not where x is 0, but that's where if you plug whatever x terms you get there, sorry, x isn't 0 there, y would be 0. So whatever the x value is, if you plug that back into your function, if it's a real 0, a real rational 0, then it's going to actually make your equation equal to 0. There will be no remainder and it will be equal to 0. But the second part of this graph is kind of nice because if I touch each one of those dots, which you can see in this graph, I touch them, it actually gives me the value of x on each one of those. Okay, now they're actually truly touching the graph at those particular points. Now you notice that the possible rational zeros that we had were a positive 1, a negative 1, a positive 1/2, and a negative 1/2. But if you look at the graph, what does it show me? There's really only 3. There's a negative 1 and a positive 1. You can see those right here. And then there's the negative 1/2. This one's actually, it's kind of tough to see how that's going. I wish I could have done it in action so you could see what it's actually touching here. But you can see that this is negative 1 right here. This is negative 1/2. And this is 1. Okay, so this particular one goes to this point, this one goes to this point, and this one goes to this point. Okay, so those 3 out of the 4 possible ones that we had discovered, those 3 are actually the rational zeros. So the other part of our answer here would be the rational zeros would be, and we put those in brackets like this. It doesn't really matter the order that you put them in. I put them in exactly as they appeared from left to right, the negative 1/2 and the 1. That's how you do that problem. Now let's look up there and make sure that we have this solution available to us. We had that the possible rational zeros were plus or minus 1 and plus or minus 1/2. I see that here. And do I see it anywhere else? There was another, I think I lost it somewhere. I had the rest of those answers somewhere. But anyway, so you're looking for those here. Negative 1/2, 1, and negative 1. Actually, it's this one right here. Okay, so just make sure you're careful when you're selecting the one that you need. But I hope that that makes sense to you. So even though you could have a slew of possible rational zeros that could fit the function, but maybe only one of them actually crosses the x-axis. And so we're going to see some more like that as well. But that's the answer to this one. I hope that's helpful.